Hey guys, Mr. McKinney here, just going over some limits involving infinity. So, as you learned in pre-cal, Boba Fett eats Dairy Queen. Wait, something like that. This is Mr. Jansen's slide. In pre-cal, you'll probably learned an acronym like Bobo Botan eats DC or something like that. If you didn't, you can ignore this slide. But this is just to remind you about that. Basically, that was a rule to help you figure out what the horizontal asymptotes of a rational function were. So if the big was on the bottom, y equals 0. That was Bobo. If the big was on top, there wasn't one. That was Botan. And if the exponents were the same, then you divide the coefficients. That was the eats DC. If you don't know what I'm talking about, go talk to your pre-cal teacher. The way this connects to calculus is the horizontal asymptotes are just the limits as x approaches positive or negative infinity. So as you're working on a calculus problem and you see the limit as x approaches infinity or the limit as x approaches negative infinity, this question is really asking you what is the horizontal asymptote. So make sure you recognize that horizontal asymptotes are just limits as x approaches infinity. So if we have a exponent that's larger on the top, when we look at the biggest exponent, I go back to my rules. If it's top heavy, that means there is no horizontal asymptote. So this has no horizontal asymptote. Oops. So this has no horizontal asymptote. In this case, it would be a slant asymptote. You would simplify this first term, and you get 4/5 x. So if I graphed 4/5 x, I would have a slant asymptote there. So it would either be approaching from here or here. And we can use Desmos to get an idea of that. Same thing going this way. All right. To find vertical asymptotes, and again, these are x values where the limit is positive or negative infinity. So for example, the limit as x approaches 2 of f of x equals infinity or negative infinity. If the limit is equal to infinity, that's going to tell you that you have a vertical asymptote in the graph. And the way you're going to find that is have reduced form of the rational function. Basically, that just means simplified form. So you're going to factor it first and then cancel out any factors. And then whatever's left, set the denominator equal to 0 and solve for x. And that'll tell you where your vertical asymptotes are. So let's do a couple of examples. If I want to find the vertical asymptotes for this graph, the first thing I want to do is factor it to see if any of the factors are going to cancel out. So on the top, I can make this x minus 4 and x plus 1. And on the bottom, I can make it x minus 4 and x plus 2. So I can cancel out the x minus 4. What's left over, I'd set equal to 0 on the bottom. So x plus 2 equals 0, subtract 2 from both sides, and x equals negative 2. So this graph would have a vertical asymptote at x equals negative 2. This x minus 4 factor, if I set that equal to 0 and I end up getting x equals 4, this is not going to be a vertical asymptote. This is where I would have a hole, and then if I wanted to know exactly where the hole is, I would take 4 and plug it in here. So my hole would be a 4, and then if I plugged it in, 4 plus 1 is 5, 4 plus 2 is 6, so I'd be at 5, 6. The limit as x approached 4 would tell me where the hole was. That's a side note though. This was asking for the vertical asymptotes. In this case, the vertical asymptote happens at x equals negative 2 because after I simplify the fraction, that's what makes the denominator 0. All right, let's look at an example of graphing a rational function and kind of putting all the pieces together. So the first thing I want to look at is horizontal and vertical asymptotes. So horizontal asymptote I can find without graphing it, without factoring it. I can just look at this first term. 2x squared over x squared, it's got the same exponent, so I just divide the coefficients. 2 divided by 1 is going to be 2. So I have a horizontal asymptote at y equals 2. All right. Then in order to figure out where my vertical asymptotes are, if they have any, I'm going to have to factor this first. So on the bottom, I'm going to make it x plus 4 and x minus 3. On the top, 2x and x. I know it's going to be 3 and 1. To get the positive 5, I'm going to need like a positive 6x and a negative x. So I'm going to put plus 3 and minus 1. Notice that in this case, I can't cancel anything out. Since I can't cancel anything out, that means there's no holes on this problem. But there's going to be 2 vertical asymptotes. So from this one, I'm going to get x equals negative 4. And from this one, I'm going to get x equals 3. So at negative 4, and then at positive 3, I have asymptotes. Now to figure out the rest of what the graph would look like, intercepts are helpful. So to find the let's start with the y-intercept. The y-intercept happens when x is 0. So if I plug in 0, 0, 0, 0, negative 3 divided by negative 12 would be 1/4. Whoops. Now you would have to plug in a lot of values to know for certain whether or not it crosses any of these asymptotes. And you can figure out where the x-intercepts are, which is also helpful. In this case, my x-intercepts happen when y is equal to 0. Y is equal to 0 if the top of this fraction is 0. So at x equals 1/2 and at x equals negative 3. So at negative 3, I've got a point, and at 1/2, I've got a point. Since I've got zeros here, my 2 x-intercepts here and the y-intercept here, I have a pretty good idea that it's going to go up and through these, and then usually on this type of rational function, at the asymptote, you're going to switch from positive to negative. But at this point, I would just graph it on Desmos or on my graphing calculator. The main thing you're going to need to be able to find by hand is the asymptotes and potentially the intercepts. You're not going to have to graph the whole thing by hand. This is just the Desmos graph that looks all nice. And look, mine was not bad. All right, one more example. So we've got 2x squared minus 7x plus 3 over x minus 4. Again, I'm going to start with the asymptotes. For the horizontal asymptote, I'm going to look at the leading term. In this case, the exponent is bigger on top, so there is not a horizontal asymptote. But there is going to be a slant asymptote, and I'm going to simplify this. So y equals 2x is going to be my slant asymptote. So going through the origin, going through the point 10, 20, something like this, I'm going to have an asymptote. For my vertical asymptote, I'm going to factor the top and see if anything can cancel out, because if it cancels out, it's a hole, not a vertical asymptote. So 2x, x. Since this is negative and this is positive, I know these are both negative. I'm going to go ahead and put 3 and 1, because I can just see that if I did it the other way, I'm not going to get 7. Negative 1, negative 6x is my negative 7x. And then on the bottom, x minus 4. Nothing can cancel out, so since nothing cancels out, there's no holes, but I do have a vertical asymptote coming from this factor at x equals 4. So over here at 4, there would be a vertical asymptote. And then to figure out where the rest of the graph goes, it's helpful to look at intercepts. So the y-intercept would happen when x is 0, 0, 0, 0, negative 3/4. And then the x-intercepts happen when y is 0. Again, when the top of the fraction is 0, which would happen at 1/2 and at 3. So 1/2 and 3. So there's 1/2 and there's 3. So I have a pretty good idea that the function is going to look like this. And it does. Again, by hand, you need to be able to find the horizontal and vertical asymptotes and the intercepts. Now, keep in mind the reason that we're thinking about graphing and looking at all these asymptotes is because the asymptotes are really just telling you the vertical asymptotes or they're telling you the limits. Let's start that over. The horizontal asymptote tells you the limit as x approaches either positive or negative infinity. So when you see a limit as x approaches infinity or a limit as x approaches negative infinity, you're thinking about horizontal asymptotes. If you see a limit that is equal to infinity, you're thinking about vertical asymptotes. So that's how we connect the things that we learned in pre-calculus and algebra 2 about graphing rational functions to the calculus that we're going to be doing this year with limits and infinities. Hope this helped. Good luck.